In a simple Atwood machine, two unequal masses m1 and m2 are connected by a string going over a clamped light smooth pulley. In a typical arrangement, figure is shown in the diagram below, where m1 is equal to 300 gram and m2 is equal to 600 gram. The system is released from rest. The larger mass is stopped for a moment of t equal to 2 seconds after the system is set into motion. Find the time elapsed before the string will become tight again. So for this particular question, the first thing which we need to consider is that this is a mass of 300 gram, and on the other side m2 is a mass of 600 gram, and the two starts moving in such a way that m1 is moving upward with an acceleration a and m2 is moving downward with an acceleration a. So we first of all calculate the value of acceleration for the system. So in order to do so, we can simply say that a force m2g, which is equal to weight of this block, is acting in the downward direction. A tension T is acting in this direction. Similarly, on m1, a force m1g, which is equal to weight of m1, is acting in the downward direction, and tension force is acting in the upward direction. So if we apply force equation for the individual blocks, we can say T minus m1g is equal to m1a. This is the first equation, and the second equation is m2g minus T is equal to m2a, which becomes the second equation for us. So if we solve the two out, we get m2 minus m1g is equal to m1 plus m2 into a. And from here we can write that acceleration which we calculate is equal to m2 minus m1 upon m2 plus m1 into g. So if we substitute the value, that is 600 and 300, we end up getting acceleration as 3.266 meter per second square. So this is going to be the acceleration for this particular mass system. Now the next aspect which we are talking about over here is the system is released from rest. The larger mass is stopped for a moment 2 seconds after the system is set into motion. So the question is saying for a moment. So this is a very crucial line over here. It is not stopped for the entire duration of time, but just for a moment. So over here we first of all calculate the velocity of m1 and m2. So m1 is moving in the upward direction, and I calculate the velocity of m1 which is in the upward direction after 2 seconds. So if we apply the equation v equal to u plus at, initial velocity is 0. The acceleration value which we calculated is equal to 3.266 into t, that is 2 seconds. So we obtain a value equivalent to 6.52 meter per second in the upward direction. Similarly, if we calculate the value for v2, we will get the same calculation, and we get the same calculation 3.266 into 2, that is equal to 6.52 meter per second, but in the downward direction. The only difference is that the two masses will move opposite to each other. Now over here the question is saying at t equal to 2 seconds, m2 stops for a moment. If m2 stops for a moment, the m1 will continue to move upward with a velocity of 6.52 meter per second, and it will continue to move till its final velocity becomes 0. So it will be moving in such a way as if it is in a state of free fall. It is because that the tension will cease to act. On stopping the larger block, the tensional force will cease to act. On stopping the larger block, tension force will cease to act. Now as a result of this, the rope will start slacking itself, and it will slack itself till it reaches the highest position. So if we calculate for the highest position, that is the final velocity to be equal to 0 for the mass m1, so we are again applying the equation v equal to u plus at. This time u is equal to v1. So we are putting it in this way: 0 is equal to 6.52 Now we are moving under the influence of gravity. So minus 9.8 into t. So from here we solve to obtain t is equal to 2 by 3 seconds. So during this period t equal to 2 by 3 second, m2 mass will also start moving downward. It is because of the fact that the mass was stopped for a moment. This is important, that the mass was stopped for a moment. So it will start its downward motion, and hence the string will again become tight after a time of t equal to 2 by 3 seconds.